Chalo. Okay, the next heading beta. Motion of a body. Motion of a body in a vertical circle. Motion of a body in a vertical circle. Okay. Now tell me, when a particle is moving in a circular path, what are all the forces acting actually on the particle beta? There are two forces acting. One is a centripetal force, another one is known as a your tangential force. That means along the tangent there is one force, and along the center there is one force which have been acting on this particle, isn't it? Let's say from center to here there is one force which has been acting, and tangent to this one there is another force which has been acting, isn't it? This one is called as of your tangential force, and this one is called as of your radial force part of relation. So the force which is acting towards the center is known as centripetal force. The force which is acting tangent to the circle is known as of your tangential force part of relation, isn't it? So
Yes.
here there will be your tangential force. So that will be equal to mass into tangential acceleration. And at the center there is one force which is acting as centripetal force. So centripetal force is equals to m into your centripetal acceleration. Now, if I'm taking a body which is moving in a vertical circle, like say for example, assume that there is a particle like this, which has been connected by a thread, and there is a small ball here right now like this. And you're standing here and you are holding this string and you're moving it in the vertical circle. General ga chedlo oka rai itla petteskoni, we'll be trying to tie a stone to a thread or maybe a string, and we'll be trying to rotate in the vertical circle or maybe in horizontal circle. Avuna kada?
Yes, sir.
So when you give it horizontal velocity right now for me, the initial length of the string when it is here, it is nothing but say for example of your L. When this string goes from here to here right now, so when it comes to somewhere at some position right now here, making an angle of your theta, making an angle of your theta part of relation. Initial velocity of this one here is nothing but u, and velocity at any instant of your time is say for example of your v. Okay, it has been raised from the ground by this much amount of a distance. I told you how to calculate this height already. So this one is nothing but of your h. This is the height to which it has been raised. So this h will be equal to how much for me? L into 1 minus of your cos theta. Gurtunda?
Yes, sir.
Isn't it? So now if I resolve this one into components right now for me, so the tension acting in the string here, it is right now equal to your T. The force acting in this one is right now in the downward direction, that is nothing but equal to your M into G. If I resolve this force into the components right now, this will be making an angle theta, and here this will become for me mg into your cos theta, and along the tangential there is one more force that is called as of your mg into your cos theta. And velocity at any angle that I'm taking it as of your theta. So this is some angle kada, velocity at angle theta is equals to how much? Is that force is clear better for you?
Yes.
Isn't it? So if I resolve this one into components right now, this is your h part. H is equals to how much for me? L minus of your L into your 1 minus cos theta part of relation. You can understand something like this. Here it will be your L. If you resolve it here, it will become for me L cos theta. And here it will become for me L sin theta.
Yes.
చూడు ఇది రిజాల్వ్ చేసుకుంటే ఇది ఎంత అవుతుంది? దిస్ ఈజ్ యువర్ ఎల్ కాస్ థీటా, అండ్ హియర్ ఇన్ దిస్ సైడ్ విల్ బికమ్ ఫర్ మీ ఎల్ సైన్ థీటా. ఇది హెచ్ రావాలంటే ఈ ఎల్ మైనస్ ఎల్ కాస్ థీటా చేస్తావా? సో దట్స్ వాట్ ఐ హావ్ డన్ హియర్ రైట్ నౌ. హెచ్ ఈస్ ఈక్వల్స్ టు దిస్ టోటల్ ఎల్ మైనస్ ఎల్ కాస్ థీటా. ఎల్ is కామన్ కాబట్టి 1 minus of your cos theta part of relation.
Yes.
So tension is acting along the string T. So this one is balancing this mg cos theta. This mg cos theta is balancing. So this will be mg sin theta. So this will be your mg sin theta here.
Yes, sir.
So this will be your mg into your sin theta. Sorry. Okay. So this is a situation part of relation. Now tell me, what is the forces acting on this one? Number one is your tangential force. First one is your tangential force. That is nothing but of your Ft. Ft is equals to your mg into your sin theta. And number two is your tangential acceleration. Tangential acceleration. So tangential acceleration is how much for me here? Tangential acceleration is equals to at is equals to your G into your sin theta. ఎలా వచ్చింది చెప్పు ఇక్కడ ఈ tangential లో you take F is equals to M into your A beta.
Okay, yes, sir.
అవునా కదా? Tangential if you take M into your A,
M and M cancel.
M gets cancelled, so this will be your tangential acceleration. So AT is equals
Yes,
to
sir.
G into your sin theta part of relation. Then what is the other force which has been acting on this one is until right now for me? Third one. Radial or centripetal acceleration. Radial or centripetal acceleration. Radial or your centripetal acceleration. So what is the centripetal acceleration formula? AC is equals to V square divided by your R. Ona?
Yes, sir.
Centripetal acceleration. So net acceleration enta? A net is equals to, we got two accelerations right now. This one is your A net, sorry, this one is your A centripetal and this one is your A tangential. So the net force will be acting in this one right now like this. Anagada, making an angle theta
Yes.
with the vertical. So this is your A net. So A net is equals to under root of, both of them are perpendicular kabatti. This one is AT square plus of your AC square. Is that clear?
Yes.
So net acceleration acting on the system is equals to under root of your AT square plus of your AC square part of relation. So when I'm talking about motion of the body in a vertical circular motion, when a particle is moving in a circular path at any angle theta, the forces acting on the body are, one is the weight mg in the downward direction, another is tension in the string. If I resolve this mg into components, this will be mg cos theta, this will be mg sin theta. So mg sin theta is balancing your v into theta part of relation, and t will be balancing your mg into cos theta when the body is at the rest condition. Isn't it? So the forces
Yes,
acting on that one are tangential force, tangential acceleration.
Yes.
So radial and centripetal acceleration are radial acceleration known as AC is equals to V square by R. So net acceleration is equal to how much for me? AT square plus of your A C square part. Tangential acceleration plus of your centripetal acceleration. Okay, now when the body
Yes.
was at the rest position, the weight of the body here, what was your mg, and tension in the string was here in the upward before it started the motion. Ante kada?
Yes.
Okay, chalo. Now apply the law of conservation of energy. Applying law of conservation of mechanical energy. What is the law of conservation of mechanical energy, beta? Total energy, initial energy must be equal to your final energy. Ante kada?
Yes, sir.
Initial energy must be equal to your total final energy. Work per energy chadve antav.
Yes, sir.
So that means initial potential energy plus initial kinetic energy must be equal to final potential energy plus final kinetic energy. Okay. Initial
Yes.
potential energy anta, when the body is somewhere here, there is no height. So initial potential energy is equals to 0 plus initial kinetic energy. Initially it is having the velocity, say for example u. So the kinetic energy of this one will become for me half into m into your u square. That is equals to final potential energy means somewhere at this position. After coming from this position to this position, it is been raised by this height. So final potential energy is equal to mg into h. This h is how much for me here? L into 1 minus cos theta. So the potential energy will be equal to your mg into h. H is nothing but of your L into 1 minus of your cos theta plus final kinetic energy. Final kinetic energy is equals to your half into m into velocity at that position, that is nothing but at an angle theta. Ante kada? ఇక్కడ kinetic energy వచ్చేసి velocity ఎంత v. ఇక్కడ kinetic energy వచ్చేసి initial energy is given how much for me u. So it is half into m into u square, and this one is half into m into your v square. So initial potential energy is 0, initial kinetic energy is half into m into u square, and initial final potential energy is mg into h. H is equals to L into 1 minus cos theta, and final kinetic energy is half into m into your v theta square. Now see, simplified whether anything is getting cancelled or not. You see, in this one, this m and this m will get cancelled. This 2 will go here right now, isn't it? So this 2 will go here right now. So this will become for me, how much can you tell me? V theta square is equals to, now see, in order to remove this 2, what I can do? I can multiply and divide this one by what? 2 divide by 2. Antena?
Then yes, sir. Then it'll get cancelled and
Will get
we'll have
cancelled. So this will become for me u square is equals to, this will become for me 2g into your L into your 1 minus of your cos theta plus this will become for me v theta square. Ante kada?
yes, sir. That also will get
So now you
cancelled.
take the v theta square outside. So if I taking the v theta square outside, so it will become for me v theta square is equals to, this one is your u square minus 2g into your L into 1 minus of your cos theta. Should this one is u square only, and I'm taking this one outside. So this
Yes,
will
sir.
go. So this will become for me v naught v theta is equals to how much for me? V theta velocity at any point is under root of, this will become for me, this one is equal to your u square minus of, this one is 2g into your L into 1 minus of your cos theta. So this is the velocity at certain angle theta. Clear?
Yes, sir.
This is your velocity part. So velocity at any angle theta is calculated by the formula v theta is equals to your under root of your u square minus 2gl into 1 minus of your cos theta part of relation at any angle. At 0 degrees kavalana, 30 degrees kavalana, 60 degrees kavalana, you can directly use this formula, you will get the answer for that. Okay, na?
Yes, sir.
Now tension at any point if I need to calculate. Next one is tension at any angle theta. Tension at any angle theta. Chudu. Now see, at any angle theta ante ide kada. This theta, isn't it? And centripetal
Yes.
force are in the same direction, beta.
Yes, sir.
And this mg cos theta is in opposite direction,
Yes, sir.
isn't it? So pseudo force will be acting on this body in opposite direction right now. So the tension at this theta naught will be equal to your how much? So I'll write here right now. This is tension at your theta naught minus of your mg into your cos theta. Both of them are opposite direction kada. That is
Yes,
equals
sir.
to mass into centripetal acceleration. Ante kada. F net is equals to, this one is something like F net is equals to mass into centripetal. Net force acting on this particle is, one force is in this direction and another force is mg cos theta in the opposite direction. So it is a T minus of mg cos theta is equals to how much for me? M into your this one. So this is your M into centripetal acceleration and V square by R. So this I can write here as V square and V at any angle, that is V theta square divided by your R. Last question.
Yes, sir.
So now theta at any angle, you write this one, theta not theta, t theta is equals to your m into your velocity v theta square divided by your r. This minus, this will go this side and means this will become for me plus mg into your cos theta. Achinda? So this
Yes,
is
sir.
the tension at any angle theta. At any angle theta part of relation. Achinda?
Yes, sir.
Sorry, my doubt on the intla. Is this equation clear?
Yes, sir.
F net is equals to m into AC రాస్తాను. AC is v square by r. At any angle theta అనుకున్నాం కాబట్టి I took the velocity at any
Okay,
angle,
okay, yes, sir.
tension at any angle theta. So t theta is equals to minus mg cos theta is equals to m into v theta square divided by your r. Okay, na?
Got it, sir. Yes.
Now, if I take different angles, like say at theta is equals to 0 degrees, that means tension at lowest position. Tension at lowest position or lowest point. Lowest point is how much? చెప్తావా? చూడు, theta must be equal to 0. అంతే
Yes,
కదా?
sir. Yes.
ఈ diagram, if theta 0 అంటే this ball is here కదా, at bottom.
Yes, sir. Finish. Finish.
Yeah. So when it comes here, it will become 90.
Yes,
When
sir.
it comes here, it will become 180. When it comes here, it will become for me 270. When it comes back again, it will become for me 360. That means 0.
Yes, sir.
అంతే కదా? With vertical, the angle made by this one is 360 degrees. Or along, it is coming in the same axis part. Now చూడు ఇక్కడ. So at any angle theta, we got answer. So theta is equals to, what is that condition I'm taking right now? Theta is equals to 0. At theta is equals to 0. Or we are talking about your tension at your lowest point is how much? So what will be the answer, beta? T at lowest position is, T at lowest position will be equal to your maximum, because cos 0 is how much, beta? 1. So that will
Yes,
be
sir.
equal to your m into velocity is u square divided by length of this one is nothing but equal to radius r plus of your m into g. Antena? Chudu ikkada. Theta value is 0, cos 0 is 1. This velocity at the lowest position is how much in the given question, beta? In the given problem, it is equals to how much for me? U. So that is the
Yes, sir.
reason
Which is
I'm taking that one as of your u part. So this is the velocity at the lowest position. So velocity at the lowest position is how much for me? M into u square divided by r plus of your m
MG.
into your g. Is it clear?
Yes, sir.
So I can even write like this as T max is equals to m into velocity at lowest position divided by r plus of your m into g. So whatever the velocity he gives in a problem, you can use that one and you can calculate the tension at that point. Okay, na? So this is the tension
Yes.
at the lowest position, and this is your general form. Okay, na? Now at highest
Yes.
position, chudunna, tension at your highest position.
Sir,
At theta
0
is equals to 180 degrees. It means
highest one.
tension, yeah, tension at highest point. Tension at your highest point. And in the formula, we need to take cos 180. Cos 180 is how much, beta? Cos 180 is how much? Minus 1.
Yes, sir.
So in this one, theta will become how much for me? M into velocity at highest position, I'll write VH. And this will become for me cos 180. Cos 180 is minus. Avuna kada?
Yes, sir. Minus MG.
So then it will become for me, T will be equal to minimum. T minimum is equals to M into velocity at your highest point divided by R minus this will become for me mg because cos 180 is equals to minus 1. Okay, now this is
Yes.
your T minimum value. T minimum value is equals to your mvh square divided by R minus of your mg. Okay.
Yes, sir.
So we got the tension at any angle. We got the tension at the maximum position, that is tension at lowest point, and we got the tension at the highest point, isn't it? So now
Yes,
see
sir.
the condition better. To just complete the circle, to just complete the vertical circle, the condition is T minima must be equal to 0. So what is the condition for a particle to make a complete vertical circular motion, beta? Minimum tension must be equal to 0. That means this minimum must be equal to 0, beta. So if T minimum is equals to 0, so we know the formula T minimum is equals to M into velocity at highest position divided by R minus of your
Minus
M
MG.
into G. So this will become 0. So it is M into velocity at highest position divided by R minus of your mg. So it bring this one, this will become for me negative. So it is M into VH square divided by R is equals to M into G. Minus will get
Yes,
cancelled.
sir.
So this mass and this mass gets cancelled. So velocity at highest position will be equal to how much, beta? Under root of your
R.
R into G. So this is the standard formula for a particle to make a vertical circle. What should be the minimum velocity at highest position and velocity at highest position for making complete or to complete the vertical circle. The condition is that T
So,
minimum must be equal to 0. If T
0.
minimum is 0, then velocity at highest position is how much, better? Under root of
Root
your
of.
G
Yes.
into your R. Is it clear?
Yes, sir.
So I can say that this is a minimum velocity at highest point to just complete the vertical circle. So I'll write this one here right now. This is minimum velocity at highest point to just complete vertical circle. Okay.
Yes, sir.
Chalo. Let us try to calculate velocity at lowest position. velocity at lowest point to complete vertical circular motion. Okay, so what should be the minimum velocity at the lowest position? అంటే నువ్వు కింద ఎంత వెలాసిటీ తెస్తే దట్ విల్ మేక్ వన్ కంప్లీట్ సర్కిల్. సో ఇట్ విల్ మేక్ వన్ కంప్లీట్ సర్క్యులర్ మోషన్. అంటే ఇది యూ వాల్యూ ఎంత, ఈ యూ వాల్యూ ఎంత ఇవ్వాలి. సో దిస్ యూ వాల్యూ ఇస్ ఈక్వల్స్ టు హౌ మచ్, ఇది యూ ఇక్కడ ఇనిషియల్ వెలాసిటీ ఇస్ యూ. Okay, so what is this u velocity? So that this body will go up right now here, isn't it? And at the highest position we know that velocity tension at the highest position must be equal to 0, and the velocity here is nothing but velocity at highest position is how much for me? Under root of your how much for me? G into your r. When you can calculate the velocity at any position better, you can calculate the velocity here, you can calculate the velocity anywhere basically, isn't it? So at the lowest position, what is
substitute the angle?
Yes, beta.
Just substitute the angle and we can find.
Yeah. Now what we can do is we need to apply the law of conservation of mechanical energy. Total energy at the lowest position must be equal to total energy at your highest position. So applying law of conservation of mechanical energy. Law of conservation of mechanical energy. Okay, total energy at lowest position must be equal to total energy at your highest position. Avuna kada? Lowest position got potential energy nanda 0. Kinetic energy is half into m into velocity at lowest position is vl square anukundam. That is equals to half into m into your velocity at highest position is vh square. Plus this one is nothing but mg into height is equals to how much better? Can you tell me? So what is the height? Going from here to here. That means what is the height from here to here beta? R and R. This is nothing but radius only kada. So this is R and this is R. So total height will be equal to how much for me? 2R. So potential energy will be equal to mg into h. H value is nothing but equal to how much for me? 2 times of your radius. Vachinda?
Yes.
Edana cancel avutunda chudandi intla. This m gets cancelled, isn't it? In order to remove this value 2, what I can multiply here right now with
2, sir.
2.
Multiply divided.
So this will become for me velocity VL square is equals to VH square plus 2 into 2. This will become for me how much for me? 4 into G into R. Vachinda?
Yes.
Now velocity at highest position ento vachindi already niku. Velocity at highest position is under root of RG. That means velocity at lowest position VL square is equals to VH square. VH square enta nana? GR?
Yes, sir. Root over.
VH square తీసుకుంటే this will become for me RG.
Okay, yes, sir. Square, that's right. Become RG. Yes.
Yeah. Plus this will become for me 4G into your R. 4 plus 1, this will become for me 5G into your R. That means velocity at lowest position is how much for me? Under root of your 5G into your R. So this should be the minimum velocity at lowest position. That means in order to make this complete circular motion, ఇది complete గా ఒక circular motion ఇవ్వాలంటే what should be your minimum velocity at lowest position beta? Under root of your 5G R. Under root of your 5G into your R part of relation. That is the velocity at the lowest position. Is that clear?
Yes.
Isn't it? So anytime we need to calculate means the velocity at this position can be calculated by this formula. If there is any other velocity given at highest position, then you can calculate the lowest velocity. Okay, no?
Yes, sir.
So this is the relation you need to remember. So for making a complete circular motion, you tell me what will be the conditions beta? Velocity at highest position must be equal to how much? Under root of GR. Velocity at lowest position must be equal to how much for me? Under root of your 5G. That means this is the minimum velocity which should be given for us.
Yes, so or else there won't be.
Yeah, this is minimum velocity. This is your minimum velocity. Velocity to be given at lowest position or at lowest point to complete circular motion. To complete one circular motion. Minimum. Okka circular motion cheyadaniki idi.
Yes.
If I make 100, that means you can increase more than this one, but
Yes.
not lesser than this one.
Yes.
Avuna kada? So here I can write now the condition. See here, to just complete the circle, to just complete circle in a vertical circular motion, to just complete the circular motion part of relation. So see here, if I'm taking the velocities for this one, this is your string and here is your ball. Here the velocity is should be equal to how much for me, beta? Under root of 5g into your r. At highest position when the ball will come, if you need to complete the circle, and here the velocity should be equal to under root of your g into your r, isn't it? So this is your radius, L is equals to your r, and when the body comes here right now, this is your particle right now. So this is your A here and this is your B, and this is the particle somewhere here right now with this velocity. Okay.
Yes.
But tell me, tension at A will be equal to how much? Tension at your A is equals to, that means at lowest position. See the formula, tension at lowest position, tension at any angle, tension at lowest position, this one. Tension at lowest position, what is the formula? M into VL square divided by R plus mg, beta.
Yes.
So you can write that value. Tension at lowest position is equal to how much? M into velocity at position divided by R plus of your M into G.
Yes.
And velocity at lowest position ento vachindana. This one is under root of your 5g r, and this will become for me 5g into your r. Antena lowest position card.
Yes, sir. Yes, sir.
Into your r divided by your r plus of your mg. So this r will get cancelled. So this will be 5 mg plus mg. How much it will be? Your 6 times of your mg. So this will be the tension at lowest position. Antena?
Yes.
So tension at the lowest position enta undala naaku right now for making the complete circular motion. So tension at this position T at your A must be equal to how much for me? 6 times of your mg. Okay na?
Yes, sir.
Now velocity at B enta avutundi cheppagaltava? You know the velocity at any angle? You know the formula for velocity at any angle? Velocity at any angle formula is under root of your initial velocity. U is nothing but what, beta? Initial velocity.
Yes.
Minus of 2g into L into 1 minus cos theta. That means I can write here velocity at point B will be equal to how much? Velocity at your point B is equals to under root of, this one will become for me U square minus of 2g into your R into 1 minus of your cos theta. So what will be the U, beta? At the lowest position, the velocity value, U value is equals to how much for me, beta? U value is how much for me? Velocity at your lowest position, VL square minus 2gr into 1 minus cos. What is the theta? Can you tell me? You're going from here to here. This will be equal to 90 degrees. So yes, this will be equal to your 90 degrees. So this will be your cos 90. So this will be velocity at lowest position. This one is 5g into your r minus of your 2g into your r. Cos 90 is how much?
0, sir.
0. 5 minus 2 is how much for me? 3. That means under root of your 3g into your r. So velocity at point B will be equal to how much, better? Under root of your 3g into your r. Anna?
Yes, sir.
So that is the velocity at the lowest position. So that is, sorry, at the horizontal position. At the horizontal position, that is the velocity. Adhamainda?
Yes, sir. Got it, sir.
Now tell me, what is the velocity at the highest position? Velocity at the highest position is how much for me? We know already it is how much for me? At point C anukundam ikkada. Idi AB vachindi kada. This one is, say for example, C. So at point C. At point C, velocity enta nana? Velocity at highest position is how much? Under root of G into your R. So tension will become how much for me, beta? Tension will be equal to how much? At highest position means, what is the tension? See, tension is nothing but how much for me? At the tension at highest point is how much for me? Vt minimum is equals to Vh square by R minus mg. Antena?
Yes, sir.
So this equals to your m into Vh square divided by R minus of your m into g. That is equals to velocity at highest position is how much? This one, kada? So substitute that one, m into g into r divided by r minus of your m into g. This r gets cancelled. So tension at your highest position is how much for me? Tension at highest position is mg minus mg 0.
Yes, sir.
Isn't it? This already we got the condition. So to complete a circular motion, what is the basic condition, beta? Tension at the highest position must be equal to how much? 0. T minimum is 0. That means the tension at highest position should always be equal to how much? 0.
0.
That is a proof what we got right now here. Is it clear?
Yes, sir.
Isn't it? So how much time is left out, beta, for the...
6 minutes, sir.
Okay, chalo. So we got the tension at point B at horizontal position. We got the tension at your point of your C part. So I hope you got rough idea how to calculate this one beta everywhere.
Yes, sir.
So this is the
Yes.
given condition. So T max minus T minimum ఎంత వస్తుందో సార్ చెప్పు. So T max minus T minimum is equals to how much? T tension at maximum position minus of your tension at your minimum position is how much? T max ఎంత ఉందన్న? T max is how much for me? That means maximum tension is at a point A. This is nothing but of your maximum. That this is T max 6 mg and this is your T minimum at highest position. So this will be your T minimum. So how much it will be better? Difference. That is 6 mg minus of 0. And that will be equal to how much?
6
Times of your mg. Okay, na?
Yes.
Sure. See this question better. Net force on M. Net force on M at B during vertical circular motion at B during vertical circular motion think and tell me during vertical circular motion. This is your circular path, beta. Okay, and here there is your center. Okay, and here is now the particle. Okay, now net force on the particle at B. This one is B and this one is A. Now tell me at point A, at point B, what all forces will be acting, beta? One force is mg in this
mg.
direction, beta. Another one is tension is acting in this one. This is nothing but T.
T. And upwards tangential.
Along the turn tangential part. Now at point B
Yes.
means at an instant. And the force at your B will be equal to under root of these two are perpendicular. These two forces,
Yes, sir.
so this will become how much for me? T square plus of your mg whole square, can I write?
Yes, sir.
So tension at point B is how much, beta? At point B, the tension, how much we got just now? Under root of, see, tension at the point B. At the point B, what is the tension we got? Tension at point A is how much for me? This one. Tension at
Yes.
point B means it will be 90, kada? So what will be the
Yes.
tension at that position? Tension at any point, you know the formula?
Yes.
Tension at any point, you know the formula. This one, kada? Cos
Yes.
90. This will become for me 0.
0.
So it is
Yes.
m into velocity at point B. Already you know how much it is. 3gr, kada?
Yes, sir. Root of square, that's why 3.
Velocity at the horizontal position. Here velocity of the B, how much we got? Under root of your 3 into gr. Ante kada? Velocity at
Yes.
point B, how much we got? Under root of 3g into your r. So
Yes.
velocity at any point, tension at point B will be equal to how much for me? M into your VB square divided by r plus mg into your cos 90. Cos 90 is how much? 0. So tension at point B, how much we are getting? That is equals to m. Velocity is under root of your 3g into your r divided by r. R gets cancelled. So tension will become how much for me? 3 times of your mg into your whole square plus of your mg into your whole square. Then,
Yes.
so this will become for me how much? 3 square is 9. 9 plus 1, 10. That means this will become for me root 10 times of your mg. So this is the
Yes.
net force acting on this particle at a point of your B. What an idea?
Yes, sir.
అర్థమైందా లేదా?
Yes, sir. Got it, sir.
So I'll give you one more example. ఇంకెంత టైం ఉందా?
2 minutes.
చలో 2 minutes లో మనం ప్రాబ్లం చేసుకోవచ్చు. See here. This one is your point of X and here is your bob. and I'm giving you the velocity here as under root of your 8g into r beta. So now when it is going here, what will be the velocity at this position? Idi B anukundam. And when it reaches to the highest position, what will be the velocity at point C? So this VC is equals to your how much? This VB is equals to your how much? And tension at B is equals to how much? Now question is find velocity of B. Will it make a circular path or not? Can you tell me? Velocity of C is how much? Tension at point B is how much? Tension at point C is how much? Will it
Sir,
make a vertical circular motion or not? Can you tell me that
yes,
first?
sir. Yes, sir.
Because it is
Because it
greater
is
than under
more
root of
than
5g.
5 GR. Yes, sir.
Okay. Now tell me what is the velocity at point B beta? So velocity at your point B will be equal to your how much for me? So what is the formula I told you? Velocity
MV.
at any angle is under root of your initial velocity, that is u square minus 2 into g into L into 1 minus
1
of your
minus
cos
cos.
theta. So
Yes.
that is equals to under root of velocity at lowest position enti ichchadu manaku. This one
Root
is
over
8g into
8
r
into GR. Yes.
minus of 2g into this r. L is nothing but equal to how much for me? R into 1 minus of cos 90.
0,
Ante
sir.
kada. You are going
Yes,
from
sir.
here to here. This will be 90. This is 0. So this will become
Same,
how
sir.
much? Can you
Root
tell me?
over, sir, root
Yeah.
over 8 GR.
8g, yeah. Root over 8g whole square kada.
Yes,
This
sir.
is 0 na.
I'm telling like final we'll get like that only, sir, because
Final how much you are getting? Under root of your 8 minus 2. This will
2,
become for
6
me
GR.
6g. So velocity at point B is equal to how much for me? 6g into your r.